Hello everyone. In this session, we will explore corrosion and its types, an important concept that explains how and why metal deteriorate when exposed to their environment. Understanding this process is crucial for improving material durability, safety, and cost efficiency in engineering applications. Let's begin. In this session, we will cover the definition of corrosion, its causes and impacts, followed by the different types of corrosion, namely dry and wet corrosion, and finally the mechanism behind each process. Let's begin with the corrosion definition. Corrosion is defined as the gradual destruction or deterioration of metals or alloys by the chemical or electrochemical reaction with its environment. Why do corrosion occurs? Metals occur in nature in two different forms. One it is native state, example platinum, gold which exist as a native metals. The another one is the combined state where the metals combine with the other elements to form compounds. From the compound, the metals are extracted by the metallurgical process. For this process, energy will be supplied and the combined form will be in its a high energy state. When the energy increases, as we know, the stability will decrease. To attain the stability, the metals will combine with its a compound so that it can lower its energy to become stable. So this is why all the metals undergo corrosion naturally. To attain the stability, the metals undergo corrosion naturally. Metals are used in various forms. They are exposed to environments such as dry gases like oxygen, nitrogen, and a trace amount of water vapor. The exposed metal surface begin to decay, conversion into more stable compound. This is the basic reason of metallic corrosion. The most familiar example for the corrosion is the rusting of iron, where the metal combines with the atmospheric oxygen in presence of moisture to form hydrated form of the iron oxide, which is known as rust. So due to corrosion, some useful properties of metals, especially the chemical properties such as electrical conductivity, ductility and malleability etc. are lost by the metal. Even though the corrosion is a natural process, whenever the metal undergo corrosion, it will have some negative results like due to the formation of corrosion product over machinery, the efficiency of the machine gets lost. The products get contaminated due to corrosion. The corroded equipments must be replaced frequently, which leads to the economic loss. Plants get a failure due to the corrosion. It is necessary for over design to compensate for the corrosion. Corrosion releases sometimes toxic byproducts that are hazardous to the human health. Time is lost in making available parts and the value of the goods is reduced. So these are the few consequences or effects of a corrosion. In the previous video, we were discussing about the definition, causes and impacts of the corrosion. So let's discuss about the types of corrosion. Basically, the corrosion is classified into two types based on the environment. The first one is dry or chemical corrosion and the second one is wet or electrochemical corrosion. So those are the two types of corrosion. Let us discuss about dry or chemical corrosion. Dry corrosion is due to the attack of metal surface by the atmospheric gases such as oxygen, hydrogen sulfide, sulfur dioxide, nitrogen, etc. Which means when the metal came into contact with this dry gases, the metal undergoes chemical changes which is known as a dry corrosion. There are three main types of dry corrosion, namely oxidation corrosion or corrosion by oxygen, corrosion by hydrogen third one it is a liquid metal corrosion. So we have three main types of dry corrosion. Let us discuss about the first type of dry corrosion, corrosion by oxygen. Oxidation corrosion is brought about by the direct attack of oxygen at a low or high temperature on metal surface in the absence of moisture. Alkali metals such as lithium, sodium, potassium and alkaline earth metals such as magnesium, calcium, tin, etc. are rapidly oxidized at a low temperature. At a high temperature, almost all metals except the noble metals silver, gold and platinum are oxidized. The second type of dry corrosion is corrosion by hydrogen. Actually, the corrosion by hydrogen occurs at two different temperatures having two different processes. The first one is hydrogen embrittlement, where the iron or the metal will be in contact with the hydrogen sulfide, where iron reacts with the hydrogen sulfide to form iron sulfide, and which releases two atomic hydrogen. These two atomic hydrogen combines together to form hydrogen gas. This hydrogen gas will be collected at the voids which develop a very high pressure, which causes cracks and blisters over the metal surface. Thus, the process of formation of cracks and blisters on the metal surface due to high pressure of hydrogen gas is called as hydrogen embrittlement. The second type of corrosion by hydrogen is known as decarburization, which occurs at a very high temperature. Here, the steel will be in contact with the hydrogen. That is, steel is present in hydrogen atmosphere, where at a high temperature, hydrogen undergoes dissociation to form atoms of hydrogen. Four hydrogen atoms are combined with the carbon present in the steel to form methane. Thus, methane gas will be collected at the voids which develop very high pressure, which causes cracking. Thus, the process of decrease in carbon content of steel is termed as a decarburization, meaning the carbon atoms will be removed from the steel when it is present in the hydrogen atmosphere at very high temperature. The third type of dry corrosion is liquid metal corrosion. This is due to the chemical action of fluid liquid metal at a high temperature. The corrosion reaction involves either dissolution of a solid metal by a liquid metal, or liquid metal may penetrate into the solid metal. Let's discuss about the second type of corrosion, namely wet or electrochemical corrosion. Wet corrosion occurs under two different conditions. Firstly, when two dissimilar metals or alloys are in contact with each other in the presence of an aqueous solution or moisture. Secondly, when a metal is exposed to varying concentration of oxygen or any electrolyte. Under these two conditions, wet corrosion may occur. Let us elaborate the mechanism of wet corrosion. Under the above conditions, one part of the metal becomes anode and the another part becomes a cathode. The cathodic part will be determined by the environment in which the metal is present. Always the oxidation of the metal will be the reaction that occurs at the anodic part, where the metal loses its electrons and it becomes a positively charged ions. As mentioned earlier, the cathodic part will be determined by the environment under which the metal is present. If the environment is acidic in nature, the cathodic reaction will be acceptance of electrons by the proton to form hydrogen gas. This is known as hydrogen evolution type of wet corrosion. Whereas, if the metal is present in a neutral environment where the released electrons will be accepted by oxygen present in the atmosphere in presence of water to form hydroxyl ion. The reaction will further continue due to the presence of two oppositely charged ions if the corrosion occurs in a neutral environment. Thus, the metal ion from anodic part and non-metallic ions from cathodic part diffuse towards together through conducting medium and form a corrosion product between anode and cathode. Now, what are the metals which are likely to form hydrogen evolution type of corrosion? All the metals which lies above hydrogen in the electrochemical series, when came into contact with a metal, they are likely to undergo hydrogen evolution type of corrosion. This image explains how the hydrogen evolution type of corrosion occurs. The metal loses two of its electrons, which will be migrated towards the surface, where the proton present in the atmosphere accept the electrons and get reduced as a hydrogen gas, which means when the iron metal contact with the non-oxidizing acids like sulfuric acid and HCl, hydrogen evolution occurs. The various reactions which happens under hydrogen evolution type corrosion are: at anode, the metal releases its electrons and get oxidized as metallic ions, whereas at the cathode, the released electrons are accepted by the proton and get reduced as a hydrogen gas. If the metal is present in a neutral environment, there also may happen the wet corrosion, where the metal will be releasing two electrons and get oxidized. The released ions will be absorbed by the atmospheric oxygen in presence of moisture to form hydroxyl ion. The various reactions that occur under corrosion in a neutral environment are: at anode, the metal loses its electrons and get oxidized as its positively charged ions. For example, iron releases two of its electrons to form ferrous ion, whereas at the cathode, the released two electrons will be absorbed by the oxygen in the atmosphere in presence of moisture to form hydroxyl ions. Since both the ions have opposite charges, these two ions will be combined together to form ferrous hydroxide, which will undergo further oxidation to form ferric hydroxide. That is, rust will be formed as the product. In the previous slide, we were discussing about two different types of corrosion, namely dry or chemical corrosion, wet or electrochemical corrosion. In the forthcoming slides, we will be discussing about the types of chemical and electrochemical corrosion. Types of electrochemical corrosion. The first one is galvanic corrosion. The galvanic corrosion occurs when two different metals are in direct contact with each other. Here the more active metal, that is the metal having more negative electrode potential value, act as anode, and the less active metal will be behaving as a cathode. For example, in a zinc iron couple, the zinc having less electrode potential value, which behaves as anode, whereas the iron having more electrode potential value will behave as cathode. Thus there happens galvanic corrosion between zinc and the iron couple. The practical examples of galvanic corrosion are steel screw in a brass marine hardware, which undergoes galvanic corrosion. This is due to the reason that iron, which lies higher in electrochemical series, which behaves as anode and is attacked and corroded, while the brass, which lies lower in electrochemical series, having more electrode potential value, which behaves as a cathode. Thus, there occurs a galvanic corrosion. Likewise, the bolt and nut made of same metal is preferred. The reason is to prevent the galvanic corrosion. If the bolt and the nut is made of corrosion, the electrode potential difference is eliminated so that we can save the metal from undergoing galvanic corrosion. How can we prevent galvanic corrosion? Since the galvanic corrosion occurs when two dissimilar metals are in direct contact with each other, it can be minimized by providing an insulating material between anode and a cathode. Here in this picture, it is explained that the image on the left hand side where there is no any insulation between the steel and the copper. So there is a maximum probability for the metal to undergo galvanic kind of corrosion. Whereas in the image over the right hand side, we have a rubber insulation between the steel and the copper, that is anode and a cathode. Here the galvanic type of corrosion is prevented by providing an insulation between two different metals. The second type of electrochemical corrosion is differential aeration or concentration cell corrosion. The differential aeration corrosion occurs when the same metal is exposed to two different oxygen atmosphere in presence of an electrolyte. If the metal is partially immersed in a conducting solution, the metal part above the solution is more aerated and hence becomes cathodic. On the other hand, the metal part inside the solution is less aerated and thus becomes anodic and suffers corrosion. The given image explains how the differential aeration corrosion occurs where the zinc metal is partially immersed in an electrolyte, zinc chloride. The part which lies above the electrolyte, which is more aerated and will be behaving as a cathode, whereas the metal which is immersed in the electrolyte, where the oxygen concentration is less, will be behaving as a anode. This is how the differential aeration corrosion occurs. The same metal exposed to different oxygen concentration where the differential aeration corrosion may occur. Here the images of practical situations where the two different types of electrochemical corrosion, namely galvanic and differential aeration corrosion, occurs are given. The examples of different types of differential aeration corrosion are pitting or localized corrosion, crevice corrosion, pipeline corrosion, and corrosion on wire fence. Let us discuss how the pitting corrosion occurs. Pitting is a localized attack resulting in the formation of a hole around which the metal is relatively unattacked. For an instance, metal area covered by a drop of water, sand or dust or scale, where the area below the drop of water will be less aerated and will be behaving as an anode, whereas the remaining area which is exposed towards the open atmosphere where the oxygen concentration is more will be behaving as a cathode. Here the differential aeration corrosion occurs due to the loss of electrons by the metal will be getting oxidized. Gradually the hole or pit will be formed over the metal surface, hence the name pitting corrosion is given. The mechanism of pitting corrosion being similar with that of differential aeration corrosion, where at anode metal undergoes oxidation which releases electrons and forms metallic oxides, whereas at cathode oxygen absorbs the electron in presence of moisture to form hydroxyl ions. These two oppositely charged ions combines together to form compound which will be further oxidized to form rust. Here the rate of corrosion will be more when the area of a cathode is larger and the area of anode is smaller. Therefore, more and more material is removed from the same spot. Thus, a small hole or the pit is formed on the surface of metal. The second type of differential aeration corrosion is crevice corrosion. If a crevice between different metallic object or between metal and non-metallic material is in contact with a liquid, The crevice becomes the anodic region and suffers corrosion. This is due to less oxygen in crevice area. The exposed areas act as a cathode. The third type of differential aeration corrosion is pipeline corrosion, where the same pipeline passes between two different soil where the moisture and thereby the oxidation concentration will be less. For instance, buried pipelines or the cables are passing from one type of soil to the another, say from clay, which is less aerated, to sand, which will be more aerated, may get corroded due to the differential aeration. This is known as pipeline corrosion. The fourth type of differential aeration corrosion is corrosion on wire fence, which happens on a wire fence where wire fence in which areas where the wires cross are less aerated than the rest of the fence, and hence corrosion occurs at the wire crossings, which are anodic. So in the previous slides, we discussed about what is corrosion, what are the causes of corrosion, what are the impacts of corrosion, and about the different types of corrosion, namely dry corrosion, which is otherwise known as chemical corrosion, and wet corrosion, which is otherwise known as electrochemical corrosion, and the theories of dry corrosion and wet corrosion and its types. Let us meet with a different topic in the next video. Thank you.